This is Mrs. John with lesson 6 for year 13 physics, and this one is about inductors in an AC circuit. So what are inductors? Now, inductors are components that are used in circuits which is made from several turns of wire. Now, when there is a change in current and therefore a change in flux, there will be an induced voltage across the inductor that opposes the change. Now, in a DC circuit, there will be an induced voltage across the inductor. I forgot a word there. Across the inductor only at switch on or switch off, since that is the only time the current and hence the flux is changing. When the current is steady, the voltage across the inductor, VL, will be 0. Now, in an AC circuit, where the current and hence the flux is always changing, there will always be an induced voltage opposing the change across the inductor. Now, looking at Ohm's law and inductors, so very similar to the capacitor. So you've got an AC source, you've got an emitter to measure the circuit current, here's your inductor to measuring the voltage across it, and the rheostat or the variable resistor is to change the current, so you can read off the voltage for changing currents. And you get this graph, which is a straight line, which tells us the voltage across the inductor is proportional to the current, and the constant of proportionality is the reactance of the inductor, which is got from the gradient of the graph. Now, what are the factors affecting the reactance of the inductor? So greater the reactance, lower the current. So greater the opposing induced voltage, lower the current. So if the reactance of the inductor depends on two things, it depends on the frequency of the supply and also the inductance. Now, XL is directly proportional to frequency, and XL is also directly proportional to the inductance, and the constant of proportionality is 2 pi, so you get XL is 2 pi FL. So why am I saying it's directly proportional to frequency and inductance? So higher the frequency, greater the rate of change of current, and hence greater the rate of change of flux, so higher the induced voltage. Now, greater the inductance, higher the induced voltage. So because V is equal to L delta I over T, hence the reactance of the inductor is directly proportional to both the frequency and the inductance. Now, on your formula sheet, it doesn't come like this. You will see XL is equal to omega L, where omega is 2 pi F. And it'll be good for you to do some questions on inductor reactance. I've done one question for you, so if you'd like to check that, here it is.